Hello, folks. A very warm welcome from my side to Conf42 Incident Management 2024. I am Manpreet Singh Sachdeva and I work for Walmart Global Tech in United States. Today, I will be talking about Kubernetes cluster security and will explain how Kubernetes has become really important in managing the containerized applications and why it is so important for us to secure our Kubernetes workloads, the applications, and to protect us against the cyber attacks. So first, let me introduce myself. I'm Manpreet Singh Sachdeva, and I carry a very diverse experience in DevSecOps, MLOps, incident management, as well as automation testing. So I'm myself certified as a Kubernetes administrator, application developer, and a security specialist as well. So I'm certified in AWS as well. I possess both solution architect as well as DevOps professional certification. I'm very passionate about security, cyber security. I consider myself as a cyber warrior fighting against the cyber criminals and protecting all the applications throughout the internet world. So we wonder, cybersecurity is one of the most, the hottest topic nowadays, because we saw an example a couple of years back about Log4j vulnerability and the damage it caused throughout the industry. All our customers were at stake. We had a big reputational damage to so many companies as well as financial damage. And cybersecurity has many ways of attacking us. The most popular way is like the phishing and optimizing the cloud resources to attack the cloud infrastructure, and way to manage out things where our worker nodes, our applications are thereby impacted. We'll talk about everything today, and we'll talk about how we can secure our infrastructure, how we can secure our workloads, how we can secure our cloud as well. So I'm really excited to share my talk, and I just hope we all of us learn together and get something out of it. So guys, let's get started. So Kubernetes cluster security, what is it, and how Kubernetes became important, and what are the advantages Kubernetes offers us? So few years back, all of us were hosted on virtual machines, bare metal servers, and then we had a revolution where everything started getting containerized. So we had the Docker containers, and we started using the applications, making them platform agnostic. Like we can use Java, we can use Node.js, we can use Python and just containerize our application and run anywhere in the system. And then Docker had its own way of orchestration using Docker Swarm, but it had its limitations where we couldn't operate on scale, and there was limitations in the resources as well. And then came Kubernetes and offered us out of the world orchestration, where we started operating at scale. All the applications started adopting the Kubernetes way of functioning. So Kubernetes was made for the applications to work on scale, and all the different applications team, they started containerizing their workloads. And today we learn that how can we leverage the real world best practices to safeguard our cloud native applications. So I'm just presenting in front of you the table of contents for what we will go through today. So we will talk about Kubernetes security in general and our multi-layered approach for the Kubernetes security, how we can secure the control plane, secure the nodes we work on, secure our applications, and how can we secure the network part of the Kubernetes. And then we will touch base on some of the real world threats and incidents which happened in the past, and how can we leverage some best practices for our workloads going forward. I'll also share some resources at the end of this session. And I think I'm just excited. So let's get started. So yeah, introducing you to Kubernetes security. So as I told you, Kubernetes revolutionized the way organizations deploy, manage, and scale applications. So the best example of Kubernetes is like you can scale in and scale out based on the auto scaling we can configure with the help of the cloud services. So Kubernetes itself has its auto scaling called horizontal pod auto scaling, where you can scale in and scale out, and you can operate the way you get the customer traffic. So that's, we are given such a great power to operate on scale, but with great power, there is a great responsibility of securing our clusters, which is really essential as it becomes a prime target for the cyber attacks. A single security flaw can lead to major data breaches, service outages, and, as I told you, so much reputational damage. In the past, we have seen big outages just based on the security vulnerabilities in our infrastructure. And that was all like maybe due to the negligence or unawareness of the teams who actually operate on scale. So here we will talk about how we can secure not only our workload applications, but also the control plane, the network policies. How can we make sure that we have certain network policies that don't even allow the access to our cluster through some IP addresses? And we'll also talk about how to manage our secrets in such a way that we don't expose our secrets and we never keep them in the plain text. We always encode them and use our secrets management systems like Vault, AWS Secrets Manager, and Azure Secrets, the way we can work in conjunction with the cloud providers and secure infrastructure. So for modern cloud infrastructure, security we know is totally not non-negotiable. Robust defenses at all layers ensure the applications remain safe from intrusions. And when we talk about security, we talk about 4 C's. So one is the cluster level security, that we will secure the platform cluster itself, the infrastructure. When I talk about cluster infrastructure, then the container, the workload which are running in containers, all is containerized. So securing our container, how anyone cannot execute inside a container, how cannot somebody just come and use the IP address and do anything on a container. So we have to secure our containers. We also have to secure the cloud, like whatever cloud provider we use, like GCP, Azure, or AWS, all have really good functionalities which we can leverage to secure our cloud. And I will give some examples at the end, like how can we also leverage the cloud, how can we secure our cloud infrastructure as well. And then we come at last to the code. Even the code has some vulnerabilities in case like we don't follow the standard coding directions which we should be following, and we don't have the right kind of levers and right, the coding directions we must be using when we are working in an agile environment. So we'll talk about that as well. Here we have a multi-layered approach to security. By securing each layer, we ensure that there is a comprehensive protection across the entire Kubernetes environment. When we say comprehensive, we mean end-to-end protection for a Kubernetes environment. The Kubernetes cluster security involves addressing risk at multiple layers. The 4 key layers basically include the control plane. It's nothing but the brain of the cluster. All of the master nodes are in the control plane, and we have to make sure that the way we manage our cluster has to be secure, and we have to apply all our security policies at the control plane, making sure we give, because always the admin has the control plane access, and we have to make sure that we follow the security guidelines and adhere to whatever the security policies are being given by our company. Like we all have our company policies, so we have to adhere with that. And then we talk about the nodes, like then we have the worker nodes in case for the virtual machines, uh, like we have the running workloads, or we also may have a physical virtual machine. Then we talk about the actual workloads, the containerized apps which are deployed in the cluster. We'll talk about how we can secure our workloads. And then we talk about the network part, which is the communication pathways that connect the services, the applications, and the infrastructure together. So we'll talk about the network security as well. So let's first talk about the control plane security. So in control plane, we have the API server authentication and authorization. So it's really important to secure this API server authentication. For that, we can implement OAuth or Open ID Connect. So that is a very strong way of authenticating, and we can also use the role-based access control policies. Role-based access control policies are very popular in the Kubernetes world. Suppose I'm part of one I'm part of one group, and the group has an owner. So as a group owner or as a part of the group, as a group member, I will only have the access to some of the functions on Kubernetes. Suppose I can, if I'm part of a developer community and I'm using a staging environment, so I may be able to list, create, delete, or do anything on a lower environment. But suppose there is a production environment, so on that my role-based access as a developer should not be able to delete any resource or should not be able to edit any resource. So role-based kind of access will enable a certain kind of ownership or certain kind of rules to a kind of the group we belong to. Suppose there is a developer group, there is a DevOps group, and then there is an SRE group, and then there are like the incident managers. So all will have a different kind of role-based access, and the role-based access will define the kind of operations they can do on a particular workload or on a particular control plane node. So this was what we spoke about the role-based access. Then we come to the HCD encryption. So what is HCD? So like we have heard this name a lot in Kubernetes. So it's nothing but a key value database where it works like the way the Redis works. So it is always encrypted at rest to prevent unauthorized access to our critical information. So it's very important to have encryption on HCD, because if we don't have encryption, we will have all our basically kube system resources vulnerable, because they will all be exposed if we don't have encryption on the HCD level. So most of the companies, they follow HCD encryption, but like even if we do a demo project, if we do just want to do a POC, still it is very important to encrypt your HCD, because a small gap in not managing HCD properly, there will be a risk to expose your resources. That is very risky. It's always recommended do a HCD encryption at rest. Then we talk about the network policies. Network policies are applied on the Kubernetes services. Kubernetes services, the way the pods or the other resources communicate with each other based on the port we expose. Network policies control the traffic between the pods. Like suppose I am in a different namespace and other app is in a different namespace. We have two apps. We don't want them to communicate. So we will ensure that we will make such network policies that we will restrict traffic between the apps. And suppose there is a database app which uses a logging app, but for them we will always want them to have a communication. So for them we will have a network policy which will allow access to and from both the apps using the ports on the service objects. So network policies always control the traffic between the pods. They minimize the risk of lateral movement within the cluster. So there are specific tools which help us leverage the network policies. Like we have Calico or Cilium. They can actually define and enforce these kind of policies. So we spoke about the control plane security. Now we will talk about how we can actually secure our node. So node level access, if somebody has a worker node level kind of an access, they can do anything. They can even remove our workloads. They can even expose the secrets. If the attackers have the access to the node, it really becomes difficult for us to control what they can do. So on the node, we know there is an operating system, so we have to harden the operating system. So how can we do that? Just start by minimizing the attack surface at the OS level. Use lightweight hardened distributions like which are very less durable. So use those kind of hardened distributions. For example, there is a Ubuntu minimal, and then follow all the CIS benchmarks for the system hardening. So CIS benchmarks are nothing but security standards which we have to follow to make sure that we are just following the guidelines set by the CIS benchmarks. Then we talk about the container runtime security. So on a node, we have the containers. So it's always better that we limit the containers access to the host system by enabling AppArmor or the SE Linux. So I will talk about the AppArmor. I'll share some resources how we can secure our runtime security through AppArmor, by which we are able to make sure that if a user is not comes in, or if a profile is not listed in AppArmor, or if it is blacklisted, it cannot access the container at runtime. So that's a really important feature where you can restrict certain profiles through blacklisting, and you can allow certain profiles with AppArmor through whitelisting. So both of the things can be done. So in this, you can only restrict the container runtime to a specific profile. By profile, you mean like there may be a user or a group of users, or a particular profile which we have created on the node which have access to some of the containers. So that can be achieved through AppArmor. Then we talk about the security on the kubelet level. So how can we secure our kubelet? The agent running on each node. So it runs as a daemon set on each node. So we can secure the kubelet by enforcing the TLS for communication. Like we can use certificates, and we have the certificates bounded with the keys. So always use the TLS certificates on the kubelet and restrict the kubelet API access. So by which if only a client has the certificate key, those clients can only use or do operations on the kubelet level. So it is always very good practice to use TLS certificates. We can always enforce TLS for communication and restrict the kubelet API. So by this, we will have no unauthorized kind of access on the node level. So only the admins who have the keys for those certificates can run commands on the kubelet, or all of the authorized users. So this was all about the node security. Now let's talk about the application security, the workload security, or how to actually come inside a container and have policies which can secure the container. So the most important thing is to not give a container an elevated level of access, that the user should not have a root kind of access, or we should not expose such kind of access where we can run all admin kind of commands. So that is really important when we talk about the pod security standards. So initially there was a term called pod security policies, which is now deprecated and has been replaced by pod security admission. So what it does is enforces the security policies, enforcing the baseline, and also a restricted or a privileged kind of access is also restricted. Then we talk about the runtime security. Continuously monitor the containerized workloads for malicious activities. For runtime security, we have tools called Falco, which will determine or detect any kind of anomalies based on the rules and the behavior patterns which we have set. I will also share the resources for Falco tool at the end of this session. So it's a really cool tool where we can apply runtime securities for the workloads. And then a very important thing is secrets management, how we manage our secrets. As I told you, some people will just expose their secrets in config maps in plain text. That is not a good practice, and these kind of config maps are available for any user to list and even copy our secrets. All the sensitive information like the API keys or passwords, first of all, should never be hard-coded. Hard-coding a password or an API key in itself is damaging and can cause a really big issue. So instead, we should use secrets management solutions like the AWS Secrets Manager, where we can store the secrets and we can rotate them after maybe 30 days or 90 days as per our secrets policy. We can also use, like most of the companies, they use HashiCorp Vault to manage the sensitive secrets information. So by using HashiCorp Vault or even Azure Secrets, we never expose our secrets, and they're always encoded in a base 64 format. So these are all the best practices which we can use to secure our workload. And secrets management is definitely a very secure way of managing your secrets or any kind of passphrases we use in our code. So moving forward, uh, we talk about the network security. So how can we strengthen our cluster security? Because one is we were able to secure the cluster, we were able to secure our workload. Now we have to make sure the way the our workload and our all of the application which is hosted on Kubernetes, how it interacts with the network, and how we can make sure that there are no attacks on the network side and we can prevent them. So we will talk about the service meshes. So the implementing a service mesh in a large scale application is almost a must, because then we will have a Istio based service mesh, which is in itself very secure because it uses the mutual TLS. It uses the mutualist TLS encryption between all the microservices which interact with that Istio service mesh. Using Istio service mesh or Linkerd kind of a service mesh will ensure that you are secure on the network level. Like if the traffic is coming, it will first come to the service mesh and then it will get routed to the workload. So it's always a very good practice to have a service mesh before your application. And then we can do a kind of security, implement security through Ingress and Egress control. Some of you folks might be aware of Nginx Ingress controller. So how we can do is that we can secure the external facing services, whatever are Ingress, the domain names which we use. Suppose we use a domain name called abc.com or something called xyz.com. So these are nothing but Ingress host names. So the way to secure them is with the help of a server client encryption using certificates. We can always use TLS certificates, and we can always use Ingress controllers. So Ingress controllers themselves have encryption implemented on their, like, the network node. So we can define clear rules for both Ingress and Egress traffic with Kubernetes network policies. So how we can leverage is that we can use our Kubernetes network policies, which we discussed are always applied on the service, Kubernetes service. With these network policies, we can use the Ingress objects and which are defined in our Kubernetes cluster with the help of Ingress controller. So all the Ingress will be defined on the Ingress controller, and all the Ingress can be basically protected with the help of TLS certificate, and that network policies we can leverage with the Ingress host names. So that is the way we can secure our incoming traffic and even the outgoing traffic through Ingress and through Ingress controllers. Then we might have heard the term about distributed denial of service attacks. The DDoS attacks, the DDoS protection is also done by Kubernetes. So Kubernetes clusters exposed to the public internet are always at the risk of DDoS attacks. So we have like cloud services which can prevent these DDoS attacks. We have like in all the cloud providers such as AWS, Azure and GCP. So they all offer us a very scalable solution where we can get protected by using their services from all these kind of attacks. Now we'll talk about a real world threat and incidents, as we are all managing or part of major incidents. We in the past couple of years we have seen major incidents in organizations coming through security vulnerabilities, and especially there was an example where the Kubernetes infrastructure was compromised and there was a lot of big reputational damage as well as a financial damage. So we'll just take that example here. So in 2021, Kubernetes security incident happened. An attacker actually gained unauthorized access to the cluster level API server due to weak authentication configurations. So as we just were discussing, that if we leave these cluster APIs exposed because of weak authentication, it can be very damaging. So there was an incident which happened in 2021 where an attacker was able to gain the access and basically destroy some of the running deployments. The compromised API allowed the attacker to basically extract the sensitive data, the secrets, as well as the passphrases, and was able to tamper with the running workloads, causing service outage, service disruption at that moment of time. So, this is just an example, just one example, but there were several incidents which happened due to same kind of unauthorized access to the Kubernetes cluster API server. How can we actually prevent it from happening? If we have a strong API authentication and a role-based access control enforcement, that is a very good way of preventing it. And as we already spoke about the HCD data encryption, it's very important to encrypt our data in HCD at rest during all the time. And another thing which we can do is do a monthly security audit, or there is maybe do an automation of the security audits to catch all kind of misconfigurations, or if somebody has taken out any rule, or if there are no role-based access being present on a cluster. So those all can be red flags, and all the companies have the InfoSec team. So they should be regularly doing these security audits to help us preventing from these kind of incidents to happen. As we spoke a lot about all of these level of securities on all the Kubernetes layers, so let's also discuss about some of the best practices which we can take away from this session and follow in our daily lives to secure our Kubernetes clusters. So I've just listed some of the industry best practices for securing the Kubernetes. So first is the regular security audits, as we also discussed in the previous slide, continuously auditing the security of the Kubernetes clusters using the guidelines provided to us by the CIS. They have set up a set of benchmarks. It would always help us to identify any kind of misconfigurations or any gaps in our infrastructure. So doing a regular security audit is a must for the applications to operate on scale. Then another way we can help our SRE teams and even the DevOps team is to set up continuous monitoring. So with the help of like real-time monitoring, we discussed about tool called Falco. There is another tool, an open source tool called Sysdig, where we can always watch for a suspicious behavior across the cluster. So Falco has rules. So if a rule for a particular workload is triggered, we will get alarms, we will get notified on our emails, on our all kind of notification channels such as PagerDuty, X Matters, where we get notified when there is a breach in some security, or if there is a rule which should not have been there, or some workload have been triggered, something which having some user is having unauthorized access. So if we have a continuous monitoring and a DevOps culture and an agile environment, that can definitely help all the ecosystem to catch the incidents, catch the issues in early stages, and take necessary actions. Another best practice for Kubernetes is a golden rule of thumb that always give least privilege to all the things. This least privilege principle is that implement role-based access control and always follow the least privilege principle. Like any developer or any user who doesn't need access or admin kind of an access should not have basically an access where they can go inside a container, run commands, or do any kind of create directories or do any kind of stuff which is not required. So always, as a rule of thumb, give least privilege to a user who is not required to do anything important on the cluster. And then with the automation, like we can have automated patching that regularly update and patch the Kubernetes components, because Kubernetes also launches the regular patching. If you follow the Kubernetes documentation, they will be releasing the security patch, I think once in a month, and it's very important to keep up with the security levels. So there should be regular patching with the help of CI/CD tools like Jenkins, which can run automation pipelines and close all the known vulnerabilities in the previous releases, and make sure that we are always up to date as per the Kubernetes documentation. So that's really important to help taking out the old vulnerabilities in the code or in the cluster. So these are the resources which I'm like sharing with my viewers. This is like how we can encrypt the data on a cluster, how we can use the another tool called Trivi. It's a very handy tool where we can secure our workloads. I was talking about sysdig. So this is the documentation of sysdig. I was talking about app armor, that how can we create a profile, create some rules on app armor, and only some specific part of the users which are part or associated with that profile can only access some of the workloads, and other users will not be able to access if we define the profiles in the app armor. Then I'm also sharing about something called seccom. So by this you can secure your network policies or the network part of Kubernetes. Then talking about more about app armor, there are some tutorials specifically for the security. Then we talk about the Falco rules, and these are the docs, the Falco rules you can go through. There's a cheat sheet for Kubernetes security, very handy for someone who implements security in day-to-day life on the clusters. And then there is a security checklist, which is also very handy for someone to host an application, or also even when you want your application to communicate with the other applications or the outside vendors. It's very important to check the security checklist. So by that you will know what are all the parameters which make sure that your the workload and as well as your node is always secure. So these are really good handy resources, and all of them are open source. So you don't need to get a license. Everything is available open source. The beauty of Kubernetes is most of the stuff is cloud native, and it is open source, and it's very easy to implement, and most of the stuff you will find on GitHub, that people have written security policies which the whole of the world can leverage. At the end, I would say security comes more of as a responsibility. We all should step up and be very open minded and take a responsibility in fighting as a cyber warrior. By because if we consider ourselves as a cyber warrior, we will find that ownership in ourselves to protect all our applications using these security best practices. So, concluding this talk, I would say as Kubernetes continues to drive cloud native innovation, security cannot be an afterthought. There should be no compromise on the security. Every layer of Kubernetes ecosystem must be fortified to protect against increasingly sophisticated cyber threats. So by adopting the best practices such as the network policies, runtime security, runtime monitoring, Kubernetes secrets management, organizations can ensure their clusters are actually secure and resilient. Kubernetes offers us a very like a niche specialist certification. So for this, you have to be the Kubernetes security specialist certification really offers a deep understanding of the security measures and empowering all the professionals to take the charge of the cloud native security. But for this, you have to be like CKA certified first, and then you can sit for an exam for CKS. But if you want to like grow in this field and understand the in-depth working of the security protocols on the Kubernetes layer, I think this is a must for somebody who is motivated by the cyber security, and wants to work in this field. So that's a recommendation I can give. This certification will really help you understand the in and out of the cluster security. So that is it from my end. A massive thank you for the Conf42 incident management team who gave me this opportunity to present my thoughts, and a massive thank you to all my viewers who were with me listening, and I hope you all gain something and you all take away really good security measures to secure your infrastructure, to secure your cluster. And by this, I would say if you have any questions, you can reach me out to the email on the screen. And I'm really again thankful for giving me this opportunity to share my thoughts. Hope you liked it. And if you have any comments, please do share. Thank you.